When we start the topic of sound and we think about the characteristics, probably the first thing everybody thinks of is the speed of sound. And there has to be a base environment that we measure this sound at. And that base environment is at 0 degrees Celsius and 1 atmosphere. And once we have established those two criteria, then we know that the speed of sound is 331 meters per second. Now, what do we mean by 1 atmosphere? Well, typically we think of sea level as being 1 atmosphere. That's kind of the standard. That's the easiest one to measure for 1 atmosphere. So when you go into the mountains, the atmospheric pressure changes, and so the speed of sound will change. So we're only going to be considering sound at sea level. A few thousand feet aren't going to make much of a difference for us to notice a change. So we'll just consider 1 atmosphere. Even in this area, we're close enough. Now, we can measure the difference with temperature. That's a fairly simple thing to do because temperature changes pretty drastically where we're at. So the velocity changes with temperature, and that is velocity. Actually, I should put it as a function. As a function of temperature is equal to 331 meters per second plus 0.60, and the units are meters per second degrees Celsius. Should write this the other way. Degrees Celsius times the temperature in Celsius. Now, there's various various speeds of sound and different materials at or at 20 degrees Celsius in 1 atmosphere. And if you look at table 16-1, you'll find some of the different velocities or speeds of sound in different materials. And the basis that we have for this table is 20 degrees Celsius and 1 atmosphere. So they're changing and finding this value, and some of these would be measured. So air at 20 degrees Celsius is 343, and this is going to be in, I'm just going to put over here, all of these are going to be in meters per second. Helium is 1005 meters per second. Some of the more interesting, water is 1440. Now that's plain water, fresh water. Seawater is actually faster. That's 1560. Have iron. It's about 5,000. And the closest one, or the fastest one they have, is aluminum. And that's 5,100. And these also have to deal with density. Now, some terminology that we use with sound. One is loudness, and that's just related to intensity, which we discussed in chapter 15, and that's just power per cross-sectional area. Or surface, some surface area. Pitch just relates to frequency. And there's a range that humans are sensitive to, and that's typically considered to be 20 hertz to 20 kilohertz. And I'm going to put this as teenager to adult. Now it turns out that babies, because of the ear structure being smaller, they don't hear lower frequencies as well. Their threshold starts at about 100 hertz, and they can hear typically up to about 40 kilohertz. That's why they always say not to play high frequency sounds around a baby. It can do damage to their ears because their ears respond to such high frequencies. Dogs are kind of a broad range. They're about 5 hertz, so they hear lower frequencies. It tends to be why scientists feel that they can detect earthquakes before humans do, is because they hear the low rumble of the earthquake, and they can go to 40 kilohertz depending on the dog. Some dogs have lower thresholds, much like humans, but there are some species of dogs that actually can hear high frequencies. And think about a dog whistle. That's at a very high pitch. Now, the equation or mathematical definition is going to be very consistent with what we dealt with in chapter 15. And that's the standard formula dxt is equal to some amplitude times the sine of the k of the wave times the distance minus omega t. And remember that k of the wave is equal to 2 pi over lambda, and omega is equal to 2 pi times the frequency. Now sometimes we'll get away with making x just be 0 and look at it in time, and we'll use positive time and positive omega. So we'll make it just a function of t, and that's just going to be a sine omega t. So these are the characteristics of sound that we're going to be looking at and investigating. But before we get into that investigation, we need to take a look at a topic of decibels. And that's going to relate to the intensity or the loudness. So come join us for the next video.